This is a Denisovan. The entire species. Every other human ancestor comes to us in bones. Skulls, ribs, pelvises, entire skeletons dug out of the dirt. The Denisovans do not. We have a fingertip bone, a jaw, 3 teeth, that is it. But somehow we can tell you where they lived, who they had children with, and what they gave us. In the next 7 minutes, I will tell you how you reconstruct an entire branch of humanity from a bone the size of a lentil. And why, in a way that matters, they are still here, inside 2 billion people alive today. The story begins in a cave in southern Siberia. High in the Altai Mountains, in a valley the Russians named Denisova after a hermit who had lived there. The cave is not particularly famous, it is one of many. For hundreds of thousands of years, human ancestors sheltered in it, warm, safe, tucked out of the wind. Families lived here, they cooked, they slept, they died. And in the dirt of the cave floor, their bones and their tools mixed together into layers. In 2008, Russian archaeologists were sifting through one of those layers. They found a bone, a tiny piece of a finger. From a child, they thought. It went into a bag, it sat on a shelf, it waited 2 years. In 2010, that bone reached the lab of Svante Pääbo, the same geneticist who had just sequenced the Neanderthal genome. His team extracted the DNA, ran it through their sequencer, compared it to every human genome they had. Nothing matched. It was not sapiens, it was not Neanderthal, it was something else. A whole new branch of humanity, discovered from a chip of finger bone the size of a grain of rice. They named the species after the cave, Denisovan. Since 2010, we have found other Denisovan remains, not many. 3 teeth, each one large. Denisovan molars are noticeably bigger than a modern human's, twice the size of ours in some cases. 1 partial skull fragment. 1 jawbone from a limestone cave in Tibet. Discovered in 2019, but not really discovered. It had been sitting on a monk's shelf for decades. A local Buddhist monk had found it in the cave. He kept it because he thought it was interesting. He gave it to scientists because he thought they might be interested too. The mandible was 160,000 years old, and it came from an altitude of over 3,000 meters. That was proof. Denisovans lived at extreme altitudes, where the air holds 40% less oxygen than at sea level, where lowland modern humans cannot survive long-term without acclimating. Denisovans could. They lived there. They raised children there. Somehow their bodies adapted. Then came Denny. In 2018, a team led by Vivian Slon at the Max Planck Institute pulled a bone chip out of the Denisova Cave assemblage. It was from a girl. She had died around 90,000 years ago, at about 13 years old. They sequenced her DNA. What they found broke the record books. Half of her genome was Neanderthal. Half was Denisovan. Not distantly related, not descended from ancestors of both directly. Her mother was a Neanderthal woman, her father was a Denisovan man. She was their first child. In all of human evolutionary history, she is the only known first-generation hybrid of 2 different human species. Her parents did not know they were making history. They just met and stayed together. Their daughter grew up, their daughter died. And a fragment of her bone survived, waiting for us to find it 90,000 years later. She showed us that Denisovans and Neanderthals were not rivals, they were relatives. And Denisovans did not only interbreed with Neanderthals, they also had children with early Homo sapiens. Long before there was writing, or agriculture, or metal, or cities. Today, if you are of Papuan or Aboriginal Australian ancestry, roughly 4 to 6% of your DNA is Denisovan. Not 1 to 2%, like Neanderthal DNA in Europeans. 4 to 6. That is not a rounding error, that is a substantial inheritance. And in one specific corner of the world, they gave us something even stranger. Modern Tibetans live at altitudes where the air holds 40% less oxygen than at sea level. Most human beings cannot live there long-term, they get altitude sickness. Tibetans do not. They have a specific gene called EPAS1 that lets their bodies function normally in thin air. In 2014, scientists traced that gene back to its origin. It did not evolve in Homo sapiens. It came from a Denisovan ancestor tens of thousands of years ago who mated with a wandering Homo sapiens somewhere in Central Asia. A species we cannot picture, a face we do not know. Their genes are keeping people alive today. We know so much about the Denisovans, and we know so little. We do not know what they looked like. We can guess heavier build than sapiens, thicker eyebrows, wider face, but we cannot draw a portrait. We do not know exactly when they died out, or if they died out. Some of the newest discoveries suggest small isolated populations of Denisovans may have survived in Southeast Asia much later than we thought. Possibly as recent as 30,000 years ago. Every year, another bone appears, another jaw, another sequence. And every year, the picture we have of the Denisovans changes. A whole species existed for hundreds of thousands of years. They ranged across half of Asia, from Siberia through Central Asia into Southeast Asia, up onto the Tibetan plateau. They loved and lost. They had children and buried their dead. And when they were gone, this is what was left. One fingertip bone in a Siberian cave. One jaw on a monk's shelf. 3 teeth, a skull fragment. That is the whole physical record. But every other trace of them lives in the code they left in the people they became. The Denisovans are gone. But look around, some part of them is still here. It always has been.